Hi, welcome to 2.4 Reflections of Functions. In this video and in this section, we're going to look at a new type of transformation called a reflection. So in our last lesson, you learned about two types of transformations. You learned about uh, the vertical translation, and this has to do with our parameter c. So the transformation we'll always take on this form will be adding c to a base function. And what happens is our base points, xy, turn into x comma y plus c. Okay? And if c is greater than 0, the graph shifts up c units. And if c is less than 0, it shifts down. Okay, that's just to recap a little bit with the vertical translation. We also have the horizontal one. This has to do with the value of d. Let's see if we can squeeze this in here. We'll say the horizontal translation. Okay, this is when we take f of x and the x value, we subtract d from it. Okay, and what this will do, just to kind of continue this over, our points x, y map over to x plus d comma y. So if we take d away in the function up here, it has an opposite effect and it shifts the other way. Okay, so we can say if d is greater than 0, we just shift to the right, and if d is less than 0, shift to the left. So those are the two rules that we did in the last section. Just wanted to recap that a little bit. Today we're looking at reflections, okay, a new type of transformation. This is going to involve a and k. And this equation here, it's kind of more of like a formula, or even like a set of instructions, if you will. It actually means nothing on its own. It just tells us what to do to some function f. So a, k, d, and c, they all represent different parameters and different types of transformations. So in and of itself, this doesn't really mean anything. It's not until we specify what f of x is, the base function. And the base function can be any one of these for now. Okay, it can actually be any function that exists, but in this chapter, we're just focusing on these fancy four functions right there. So, and lastly, we do want to not only just graph these transformations, but we also want to be able to state domain and range for them, and maybe answer any other questions about them. So uh, that is going to be our success criteria for today. I'm just going to highlight the two new ones that we're going to do. It's going to be A and K. All right, so reflections. Reflections is basically, it's just a transformation. Okay, transformation in which a figure is reflected over a reflection line. So here's a nice example of one. We have the word reflections, and when it gets reflected over this dotted line, the image kind of gets, it actually gets reflected, but you can see it doesn't appear the same way. You can't read it because it's kind of like upside down and a little bit inverted, if you will. So this would have to be the reflection line. So the way I like to think about the reflection line is, if this is a sheet of paper and you were to fold it along this dotted line here, this image would map over exactly on top of this one. That's how reflection line works. Also, common points are equidistant, And what I mean by that is like, let's say this part of the R, the distance from that to the reflection line is the same distance as it is to that one. So they would be equidistant. So that's a property that's true with reflections. All right, we're going to start a quick investigation. Let's pull up Desmos. I didn't save a link to it because this one's pretty easy to just build up. So we'll type in our function f of x to start off, our base function, and we're going to equate it to root x. Okay, that will be our base function. I'm going to change this to black. Okay, that's a good color for a base function. And now we're going to build some new ones. So our new one will say g of x, and we'll let it equal negative f of x. Okay, so we can kind of see what happened here with this one. Our base function is f of x root x, and when we multiply f of x by a -1, or we have like a -1 in front of the function, so it's being multiplied, well, it just reflects the function along the x-axis, so along this line right here, the x-axis. Okay, so why don't we say that in here? So what is a line of reflection? So when it's in this form, we can say it reflects along the x-axis. That is the line of reflection. Okay, let's look at our new one. We have h of x. So notice functions can have any name. So we have h of x for this next one, and we're told to make it equal to f of negative x. And let's change the colors for this one here. Let's make this one orange. Okay, and we can see the graph has reflected along the y-axis. Okay, notice what happens here. We got a point. Let's grab a point here, like let's go to 9. We should see 9, 3 here. 9, 3. And I should have that on this graph too. Negative 9, 3 we should see. Okay, so those points get reflected. So think of it as folding this along the y-axis. The black graph would end up on the orange one. So when we change x to negative x, we're actually just reflecting along the y-axis. Okay, we have one more to do. We have I of x, which is equal to negative f of negative x. Okay, and I can turn the other ones off for a second. Okay, so this one here, it looks like it's a combination of two. So to go from the black to the red, you would have to reflect along the y-axis, which would be right here, to get the orange one. And then you could take that orange one and you could reflect it along the x-axis and then get the red one. Okay, you can actually see, if you look at it here in Desmos in line 3, if we take that yellow graph and then multiply it by -1, it then reflects along the y-axis. Okay. So this one reflects over 2. So we'll say reflects along x and y axis. Okay. Does it matter which one, excuse me, does it matter which one we reflect first? So can we reflect along the y and then the x? Will we get the same result as if we reflected along the x right away and then the y-axis? So let's turn this off. If we were to reflect along the x-axis first, the black would turn into the purple. Okay, and if we took that purple function, this one here, and if we replace the inside x with a -1, we would get this here. And yeah, it looks like the purple could reflect over the y-axis and get there. So this just kind of shows us that the order doesn't matter for the reflections, which one is done first. Okay, what is the equation of I of x? So here we have the function. I like to write out the equation. So I'm just going to switch over to green and I'll just say I of x is equal to negative f of negative x. Well, if I were to apply these transformations, we'll say, to this base function here, it means I got to put a negative x in for x. So I got to switch this x with a negative x, and then I got to multiply by a -1. So I would have negative root negative x. Okay, and this is okay. It's okay to have a negative symbol underneath the root. What it means is that you can only plug negative values for x in here. That way you would have the two negatives would work out to a positive. So this would be the equation for I of x. All right, what parameters from y equals a, f of k, x minus d plus c relate to reflections? Well, if you notice here, the reflection along the x-axis, that's this one here, we have a negative in front of the function. So it looks like it would tie in with the a value because that's in front of the f in here. So on the second type, when we reflect along the y-axis, we have a negative x instead of x. So that negative in front of the x, that looks like that would correspond with the k value. So we can just say a and k relate to reflections. Okay, that's the kind of transformation they relate with. So if a is -1 or if k is -1, then the functions will reflect.